Hi, I'm Jordan.
And I'm Kit.
Welcome to Starry Time, where stars plus lines.
Equal stories.
In today's episode, we'll be talking about the astronomy and other cosmic background of the constellation Serpens, the serpent.
Jordan, I have great news to start the pod today because Serpens was identified by our long lost friend, second century astronomer Ptolemy.
Our guy Ptolemy, finally! It's been a
Mm,
while. We've had to deal with some Lacaille, a lot of the
mm.
scrap heap, some Herschel. I'm glad we can get back to the OGs.
Yes, so Serpens was identified in his Almagest, making it one of the great 48 constellations. In modern times, Serpens is actually two non contiguous parts of the night sky:
And these two parts are known as Serpens Caput
the head,
and Serpens Cauda.
the tail.
So it's two constellations that are considered together. Serpens Caput is larger at 428 square degrees, and Serpens Cauda is 208 square degrees. But since we're considering them both together, they come in with a total of 637 square degrees.
And this makes Serpens the 23rd largest in size among the 88 modern IAU constellations.
Kind of feels like cheating a little bit, since Serpens Caput should actually be between Aries and Capricornus, which are more mid-sized constellations, and Serpens Cauda is way down there by Microscopium, which we just talked about last month.
I think we should draft a letter to the IAU in the most strongly worded of terms. In our next episode, we'll talk more about the history of this constellation in other astronomies. But for now, let's move on to our first impressions of this constellation. What did this constellation, either in parts or as a whole, look like to you, Jordan?
This one I thought actually had some serpent-like figures here. The first thing that made me think of was a skip it, and that, which was a
Mm-hmm.
little thing you could put around your feet and try to jump over. And then the next thing was the
Mm-hmm.
same sort of type of thing, like a jump rope or some sort of just like long line. How about you? What did you see, Kit?
Well, I started looking at the two parts separately. And I mean, of all the animals that we've talked about, that we will talk about, snake is probably the just the lowest bar that you could possibly have. And indeed, the caput part of Serpens has a little polygon head and a straight body. And the cauda, the tail is just a long line with a bend in it. So I mean, yeah, nailed it, I think. Snake.
Sometimes they get it right, and to be fair, snake is one of the easiest cells for constellation.
Yeah, definitely. But I suppose these aren't super helpful descriptions of how to find this constellation, since I think you could make basically infinite snakes out of the night sky.
It's kind of surprising we don't just got 88 different types of snakes for each constellation. That would have really simplified things.
Great point.
One thing that does help identify this constellation, however, is that it is wrapped around Ophiuchus, the serpent bearer, who we met all the way back in season one as our secret 13th member of the zodiac constellation.
And that's the justification for breaking up these two parts of the constellations. And indeed, in some older star maps, you'll see Ophiuchus and Serpens as one constellation.
Which I guess honestly would have been a little bit easier to find.
Definitely. Let's get technical and help everyone out there find Serpens Caput and Serpens Cauda.
So you can find Serpens Caput around 16 hours right extension and 10 degrees north, and Serpens Cauda around 18 hours right extension and 10 degrees south declination.
And obviously, Ophiuchus is between them. So if you listen to the Ophiuchus episode and use those cues, you might find that helpful as well. But if you're looking for Serpens Caput, you are going to find Corona Borealis to the north, Virgo to the west, and Ophiuchus and Hercules to the east. Meanwhile, for Serpens Cauda on the other side of Ophiuchus to the northwest, Sagittarius to the south, and Scutum and Aquila to the east.
Serpens is a northern hemisphere constellation. It's visible between the latitudes of positive 75 and negative 65 degrees. And the best time to see it, lucky you, is sometime between May and August, when it will be higher in the night sky.
Now that we know where Serpens is, how to find it, and when to look for it in the night sky, let's talk about the stars in this constellation. There are 11 main stars in the constellation, with only one that's brighter than an apparent magnitude of 3.
Somewhat visible across various levels of light polluted night skies, but it's not necessarily going to stand out. Of course, among brighter stars like Vega or Capella or Rigel, which we've talked about before in our episodes on Lyra, Auriga, and Orion. But surely, if there's just one big star and one bright star and then 10 other stars, Bayer has to have gotten this one right then, yes?
Oh, yes, indeed. He got it right. The brightest star in this constellation is Alpha Serpentis, and the IAU has given this the name Unukalhai, which comes from an Arabic phrase meaning serpent's neck. And so, unsurprisingly, it is located in the Caput section of the constellation. It has a visible magnitude of 2.6 and is about 74 light years from the Sun. It's a red giant star that's 1.6 times the mass of the Sun, and it's suspected of joining the red clump part of the HR diagram.
For more on the red clump branch, be sure to check out our prior cosmic background episode on Leo Minor.
Alpha Serpentis is a K-type star, and it's also a CN star.
A CN star, do we know about that already? What does that mean?
Yeah, we haven't talked about CN stars yet. A CN star has a stronger than expected for the class of a star Cyano radical bands, which means we're seeing in the emission spectra particular absorption indicating cyano radicals, which are one carbon and one nitrogen atom.
So that kind of reminds me of some of the chemically peculiar stars we talked about a little bit ago, where there's just something maybe a little different about the spectra, though in that case it was helium and different metals.
Exactly. So in this case, and in the case of CH and C2 stars, we're talking about extra carbon, and that makes Alpha Serpentis a carbon star. Carbon stars, in turn, are generally cool red giants, where in the process of burning through their fuel, when their helium fuses into carbon, some of that carbon sort of gets tossed up into the surface of the star. So what's unique is not so much that there's carbon there, or even that there's more of it overall, but that it's being brought up into the top layers of the star.
Which affects the emission lines and then the spectra as we view it, right?
Exactly. And so these type of stars were identified in 1949 by American astronomers J.J. NASA and W.W. Morgan.
Wow, did they coordinate that together? What names? Double initials.
Very good. Jason John and William Wilson, which is a tough name to say. But in 1953, Nancy G. Roman identified more than 4,000 of them.
That's an important name. Welcome to the pod for our first time, Nancy G. Roman. We are going to be adding her to the asterism list immediately.
Absolutely.
Just a little sneak peek, she was the first woman executive at NASA and was NASA's first chief of astronomy in the 1960s and the 1970s. She was absolutely critical to the development of the Hubble Space Telescope, and now there's a telescope named after her.
Yeah, I can't wait to do a pod on her. That's going to be a lot of fun.
In the meantime, Kit, let's adventure on into the most precarious segment of our cosmic background episode, Bayer's variable star.
Much maligned. In this segment, we try with varying levels of success to follow the Greek alphabet to learn more about the Bayer-designated stars in the night sky. In Microscopium, we learned about both Epsilon and Zeta Microscopii, which was exciting and puts us at Eta. Is there an Eta Serpentis?
Kit, I am incredibly happy to report that there is.
Oh, we are back!
Bayer
Bayer's variable star is back!
baby! The alphabet, it's all working out. The Odyssey, we returned home, both to Ptolemy and Bayer.
Whew.
Eta Serpentis is located in the Serpens Cauda, which we already learned is the tail of the snake. In ancient Chinese astronomy, the star is known as the 8th star of the left wall of the heavenly market enclosure. And it got that name because, well, it's the 8th star of the asterism known as the heavenly market enclosure.
It makes sense.
It does not, in fact, have a formal IAU recognized name, unlike other stars that we've discussed today. And while this is the brightest star in the tail part, the Cauda of the constellation, it has an apparent magnitude of 3.26. It's a red giant that's located only about 62 light years from the Sun. It is a single star system and unfortunately does not have a single known, at this point, exoplanet.
Boo.
Well, just not yet. We don't. We're discovering new ones all the time. Interestingly, Eta Serpentis was classified at one time as a carbon star, a CN star like Alpha Serpentis, but turns out it isn't.
Science is always revising and resubmitting and learning and updating.
There isn't much else about this star to note, except it is 1.6 light years away, which is pretty close by galactic standards to something a little bit more notable in the constellations, which is Serpens Gliese 710.
Oh yeah, this is actually a really interesting star. So tell us more about it because it was a strong contender, spoilers, but it didn't win my gold star.
Gliese 710, also known in my heart as HIP 89825,
hmm
is a main sequence orange star about half the mass of our sun. Currently, it's located at 62.3 light years from the sun. It's moving closer to us and is expected to pass the sun at a distance of 0.17 light years in a sweet, cool 1.3 million years from now. A paper from 2010 gave this star an 86% chance of passing through the Oort cloud and suggested a 1 in 10,000 chance of it passing within less than 1,000 AU from the sun.
That's really close. So even if it doesn't go through the Oort cloud, its gravity certainly could send some asteroids hurtling all around. Has something like this happened before? Something this close?
Well, in the timescale of the universe, this isn't exactly an uncommon event. But the last time this happened was around 70,000 years ago. Recent estimates suggest that Scholz's star, a red dwarf star, and its brown dwarf companion likely passed through the Oort cloud at a distance of at least 1.9 light years from the sun, and potentially even as close as 0.82 light years from the sun. And so Gliese will be the next closest flyby. It's going to take, 1.3 million years plus 70,000? But it will be brighter and more massive of a star than our last visitor.
Let's take a quick break and then we can come back and I'll tell you all about my gold star.
Welcome back. This segment is called Gold Star. In this segment, we alternate picking the star or space object in our constellation of the month that captures our mind, our hearts, perhaps even our very souls. Where did you go with this one, Kit?
This was remarkably hard, and I'm glad that you gave us the rundown on Gliese 710 because that was definitely on my short list, as I mentioned. There's a lot of really interesting star systems, galaxies, and nebula in this area of the night sky, in part because the tail of the constellation does intersect with the galactic plane.
Which basically gives us a window into a lot of different parts of the galaxy.
To that end, I had two honorable mentions that I want to toss out there before revealing my gold star.
Serpens coming in hot. I'd love to see it. Let's have one.
All right, my first honorable mention, runner-up, is Hoag's object.
Hoag's object. All right, so as far as I can tell, this is an object perhaps discovered by someone named Hoag.
Yeah, technically, yes. It is a ring galaxy located in the head part of the constellation. It was discovered by Arthur Allen Hoag. He was an American astronomer who lived between 1921 and 1999, and he was a really, really big part of the dark sky movement, which is focused on reducing light pollution.
That's actually really cool. My bad, Arthur Hoag. Thank you for all your work. But okay, what's the deal with this ring galaxy?
So, Dr. Hoag initially classified it as, and I quote, a perfectly symmetrical planetary nebula, which was unusual for a planetary nebula, and he wondered if it might be, and I quote, a new species among the pathological galaxies, that is, a peculiar galaxy.
Perfect.
Yeah, so we have an incredible image of this galaxy from Hubble from back in 2001, which essentially shows a yellow center surrounded by a circle of blue. And the yellow center is comprised of older stars that are surrounded by younger hot blue stars.
So the two different star types suggest two different populations of stars then, right?
Right, they're born at different times, and there isn't consensus on what created this particular object, as usually there'd be signs of collision between two different galaxies that would result in a formation like this. So it's still a bit of an astronomical mystery.
All right, that's pretty intriguing. What's your second
Mhm.
runner-up honorable mention?
So that has to go to Seyfert's Sextet, which, like the Leo Galaxy Quintet we discussed back in our Leo episode in season 1, is a collection of galaxies that are all on a collision course to becoming one elliptical galaxies.
So sextet, that means what? 6 galaxies here?
No, no, it's kind of like four and a half.
That's harder to say. What's that in Greek? All right, 4.5.
So, one of the objects that's counted towards the six is actually just sort of a long tail of one of the main galaxies. And one of the galaxies that appears to be in this group is actually 700 million light years away. So, it's not close at all. It's just one of those sort of things that looks close in the telescope but are not. But either way, it is stunning, the images of it, and therefore it gets an honorable mention.
These are both great choices, and the images that we have of them from the Hubble are extremely compelling. But these aren't the winners, are they, Kit? What ultimately was your gold star winner?
Well, much like the Crab Nebula choice in Taurus, I had to keep it really basic here and select the Eagle Nebula, aka Messier 16 or NG 6611, the Star Queen Nebula.
Wow, 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 wow. Star Queen Nebula, that might be the best one that we've done in the 3 years of this pod.
Pretty compelling. This nebula is an open cluster, and it was discovered by Jean-Philippe Lois de Cheseaux, which is the name that I can't pronounce of a Swiss astronomer who was also the first to point out what is now known as Olbers paradox.
Olbers paradox, also known as the dark night paradox, is the idea that the universe is infinite and unchanging, so therefore it should be pretty bright, right? All the light from all the stars would eventually have to reach Earth.
And of course, that's not how we observe the night sky. And so therein is the paradox. Anyways, Jean-Philippe gets credit for this discovery in 1745 or 1746. The nebula itself is an emission nebula with a lot of new star formation that's roughly 70 by 50 light years, so pretty large swath of space. While people may not be familiar with the larger nebula, I think many people will immediately know the Pillars of Creation, which is a region of this nebula that was photographed and imaged with the Hubble Space Telescope in 1995 and released one of the most, I think, iconic astrophotography photos that are out there.
Absolutely. And a recent JWST image of this area of the Eagle Nebula, pretty good too. One might even call it equally as captivating.
This area of the nebula, the Pillars of Creation, are comprised of what are termed elephant chunks, which are gas and dust. They're also known as cold molecular pillars, which are shaped by stellar winds and radiation from new stars. A recent NASA post described the pillars as, and I quote, like archers and spires rising out of a desert landscape. And the ones observed in this part of the Eagle Nebula are 4 or 5 light years.
So, for context, the distance to our closest stellar neighbor, Alpha Centauri, is a little over 4 light years away. And our furthest probe, Voyager 1, has been traveling for almost 50 years, and it's only approaching about 24 light hours away.
Yeah, so the pillars are immense. They're huge. And I will, of course, post pictures and more information about the research happening in this area of the night sky on our socials, universedon.com/@StarryTimePod. Be sure you check them out soon because at least one study suggested that these pillars will start to be destroyed due to a possible supernova shockwave that will become visible to us in about 1,000 years. It's still a little TBD if the shockwave was an actual supernova or if the pillars will have a more gradual demise. But, better safe than sorry. Look at them while you can.
Welcome to the Gold Star of the Month Club, Eagle Nebula's Pillars of Creation. We are happy to have you among our ranks. This brings us to the end of our exploration of the cosmic background of the constellation Serpens. Next week, we'll be exploring the myth of this constellation.
This has been Kit,
and Jordan,
sisters who love stars and stories.
and we'll see you next time.
And story time.